On the learning guide, what I tried on Thursday, I tried to discuss quality of complex numbers with you, and also the notion of what we call the modulus of actually the conjugate of a complex number. And then I did some other trick or two, and then we came up with the product of the complex number with the modulus is equal to the square of the modulus. Okay, but anyway, so I just want to stress these things again because of technical issues I had and that you also experienced. So we will look at, of course, the standard form that we know, the form A plus bj, as I stressed the last time, and I'll stress it again. So the complex number z is equal to A plus bj, where A is the real part and B is the imaginary part, and j is the square root of -1, okay? And then for equality of complex numbers, if you have two complex numbers and you are told that A plus bj is equal to C plus dj, then this can only be true. This is true if and only if A is equal to C, so the real part is equal to the real part of the other one, and the complex part of the one complex number is equal to the complex part of the other number. Okay, so this is module 4, learning unit 1, and where I've just defined a complex number z for you. Okay, and here A and B they belong to the real numbers, the elements of the real numbers, and of course j is the square root of -1. Okay, so in that section 2, and this is just stressing what I said, A plus bj is equal to C plus dj, if and only if A is equal to C and B is equal to D. Okay, right. So let's proceed then, if you guys are fine with the whiteboard. Then there's the notion of the conjugate, which I think I stopped there the last time, the notion of the conjugate of a complex number. Okay, so let's see quickly. I just need to sort out something. Okay, guys, ready? Okay, great. Right. So with this notion, let me just do that. So conjugates of complex numbers. So the conjugates of complex numbers. So the conjugates of complex numbers. So if z is given as A plus bj, and z conjugate, and then the conjugate that's how we denote the conjugate. The conjugate of z is equal to A minus bj. Okay? So you can see that the part that's affected with that definition is the imaginary part. Okay, it's this part here. There's a sign change there that occurs. Okay, right. And maybe I'll say something later about the multiplications again. I did something with you, but let me just go on with that where I stopped the last time. And this is a property that you'll use frequently. If you say z multiplied by z conjugate, of course this is commutative, guys. Okay. I mean, this is like saying z conjugate times z, the same thing, right? So if you want to do that multiplication, I think that's where we stopped the last time when I struggled to the system, but it's fine. So A minus bj, and let's do that multiplication. So I'm going to do the standard multiplication that we use sort of for real numbers, okay? Of course, we already know now that j squared is equal to -1, okay? So when we do this multiplication here, we take note of the fact that j squared is -1. So let's do that. So A multiplied by A is A squared, and A multiplied by minus bj is minus ABJ. And now I consider bj. I multiply bj with the other two terms in the next factor, okay? So now I say bj times A. This is ABJ, because AB is equal to BA, Let me just do this nicely here, guys. Just do this nicely here. All right, ABJ. So that's BJ times A. And then now comes this part. B times B is B squared, and J times J is J squared. So this is this part here. Last. Yeah, multiply those two now. This is for this here. So you guys can see there's a cancellation of these two middle terms. And then what we remain with is A squared minus B squared, and J squared, like we said, is -1. Ultimately, we end up with what we call a later jargon that you'll encounter. This is called the square of the modulus of a complex number. So for now, I'll just write it as, I write it like this, but you'll see this is the notation that we'll use basically later on. You'll see when we draw the Argand diagram and other stuff. So for now, let me just state that. Very important quantity. But let us go on to an activity quickly. So let's try and get, for example, some conjugates of complex numbers. Activity, I think there's activity 3. Let's look at some activity 3. And let me just write down what they were asking there. So for activity 3, they say write down the conjugates of the following complex numbers. So determine the conjugates, or write down. Determine the conjugates of the following. So I'm just changing the wording. I'm just paraphrasing it. Determine the conjugates of the following complex numbers. The following complex numbers. Right. So they are given as follows. So this is one. So I just paraphrase. They say write down the conjugates. I say determine the conjugates. Same thing. So the first one is 3 plus 4j. And then the next one, the B part. So I'll do selective. I won't do everything. In fact, no, let me do everything. They all look nice, actually. And then 7j. And then so this is 7j. And then the D part asks you for the real number 12, which is also a complex number. Remember, guys, every real number is a complex number. Not every complex number is a real number. Okay, right. So, so for this part here, we know by definition for the conjugate, this is the part that changes. The sign changes there. The sign of the imaginary part changes. Okay. So that's what we have to bear in mind. So A is the real part, and B is the imaginary part. We know that A and B are both real numbers, but let's square root of -1 because the B is attached to it. And that's an imaginary number. Because B is attached to it, we call B the imaginary part. Okay. So logically, for this one here, I'll just write down the answer. It's 3 minus 4j. There's a change here. Okay. And this one here, for the B part, it's just 5 plus 2j. Again, there's a change there. And of course, this is an imaginary number, so this will just be minus 7j. Well, this is a real number. The real numbers are not affected. The real part is not affected. This real part is not affected. You can even see for the 3 and the 5 on A and B. It's unaffected. It stays the same. And by the same token, the 12 will remain the same. 12 remains the same. Okay. All right. So there are your conjugates. So it's 3 minus 4j, 5 plus 2j, and minus 7j, and then 12. Right. Let me stop and ask and check with you guys if there are any questions that you have. That's fine with that. And then we can just solve maybe some 2 equations there. Okay, great. Thanks, Adir. No questions there. Okay. Okay, it's an older thing. Okay. Well, I don't see any questions. I trust that everyone's fine as well. Let's just solve some quadratic equations. We'll probably use the quadratic formula. And I'll just remind you of that formula again. Normally we use factorization, but sometimes it's easier to use the quadratic formula. So on the same activity number 2, let me just go back to the whiteboard again. So for activity 3, number 2, they also say, for number 2, they say solve the following quadratic equations under the same activity. Solve the following quadratic equations. Okay. Let's just see. I'm just going to remind you of the quadratic formula which you guys have encountered. So just a reminder. Just say a reminder. You guys know from high school that by completion of the square, you guys can solve something like this quadratic equation. You can find the roots of this equation where A, B, and C are constants, okay? So if I say solve that equation, I think it's around grade 10, you guys were able to come up with this little formula, x equal to plus or minus b, sorry, x equal to minus b, plus or minus the square root of b squared minus 4ac, and all divided by 2a, right? Right. So it's a simple way. I think you can solve this problem probably in 4 steps, and then you come to that little formula, okay? So some of the things we encountered down now here that I'll write down, these equations, we'll have to solve them using the quadratic formula. So there's x squared plus 4 equal to 0. And then the b part is 2x squared plus 3x plus 5 equal to 0. And then the c part is x squared So the c part is x squared plus 2x plus 10 equal to 0. Okay. So let's look at the a part there, guys. Let's look at the a part. Let's look at the a part for number 2. Well, with this one, we can just, what you can do, yeah, we don't need to run to the formula. This reminder thing here, the formula. We don't need to employ that to solve x squared plus 4 equal to 0. We can just say the following: x squared is equal to minus 4. And of course, you can already see for the real numbers, it's not possible that the square of a number can be negative. Okay, it should be positive or 0. So anyway, but it's fine. So what we do is we say, let's take the square root on the left and the square root on the right. Okay, so the square root on the left and the square root on the right. That's what we do there, okay? And then what we do next, well, we know the square root of x squared. Square root of x squared is x. Okay? But of course, we'll end up with a plus or minus there. We'll end up with a plus or minus there. So we have to bear that in mind, okay? So we have to bear that in mind. Remember, they'll end up with a plus or minus. So anyway, let's say the following. Let's do this systematically. So it's x equal to, and then what we do here, we just say, okay, we take out the square root of 4 times the square root of minus 1. So this is plus or minus. Okay. Like this, we have clarified. This is my j. Okay. So we'll have plus or minus 2j. That's that one. So we didn't really need to find the we didn't really need to use the formula for that one. Okay. Right. And then as we proceed, let's look at this for these other two. In fact, let's just do one of them. Let's do the B part. You can do the C part on your own, okay? So this one is fine. For the B part and the C part, you'll use the formula for the C part. I'll also use the formula for the B part. Let us just identify A, B, and C here. So A is equal to 2, B is equal to 3. I'm going to employ the formula, and C is equal to 5. So I'll substitute those values in the formula on the right-hand side. Okay. Right. So I just want to check if I wrote down everything correctly, guys. 2x squared plus 3x plus 5, that's fine, equal to 0. So let's solve that one, the B part. Let's use the formula on the far right. Let's use the formula on the far right. So x is equal to minus b. Well, b is equal to 3 plus or minus the square root of b squared, which is 3 squared, which is 9, minus 4 times a, which is 2, and c is 5. Okay, all divided by 2a, and a is 2. I'm just substituting those values into the formula. Okay, right. So that ultimately, this is minus 3 plus or minus the square root of b squared, which is 9, minus 4ac, that's 30. So it's minus 21. So it's 8 times, sorry. 4 times 2 is 8 times 5 is 40. So it's 9 minus 40, it's minus 31 over 4. Just take this right. Okay, sorry there, guys. Right. So there's that. Let me just do this nicely, guys. So in fact, this thing is too long here. I don't need to do this here. That's the problem. So there's it. So now we have what we required. So we say minus 3 over 4 plus or minus. And then we say the square root of, and then everything that we're writing now will be also divided by 4 here. Also be divided by 4. It's plus or minus. And then we look at how to split up that square root of minus 31. Right, we look at how to split up the square root of minus 31. So we say plus or minus the square root of 31. And then there's a square root of minus 1 also, which is j. That's our j part, okay? Right. So that ultimately you have negative 3 over 4 plus or minus, and then this is j, so that's okay. So it's square root of 31 over 4 j. If you want to, you can just write it in, you can leave it like that, or you can write it in a decimal form, okay? In a decimal form. So, or you can just leave it like that. Of course, that j that you see there, guys, that j is on top, right? So let me not write it there. Let me just to avoid confusion, let me just write it on the top side. So there is the j, okay? Right. Okay, so you guys can just maybe look if that activity is correct. But it should be fine. Yeah, it's fine. Yeah. So they write the j in front sometimes at the back. I don't. Yeah, doesn't matter. They put the j in front there. Doesn't really matter. I'm just trying to stick to a plus bj. So I put the j in the second position. Okay. Right. So you guys can attempt the C part in your own time. Perhaps you did it. So I just want to check if there are any questions for clarification. So I want us to go to what we call the Argand diagram, okay? The Argand diagram. So where we have a representation of the complex number in the Cartesian plane, okay? So like they say, it may be represented pictorially on the rectangular Cartesian, on the rectangular Cartesian axes. And the real, for the real numbers, we use the x-axis. And for the vertical axis, which I'll draw now, we call it yj, is the imaginary axis. Okay. So there don't seem to be a question. Okay, no problem. let's just proceed there. So let's call this section 3, and it's the Argand diagram, okay? So here you just have a pictorial representation of a complex number. And much like a point consisting of two components, an x component and a y component in the Cartesian plane, in a similar way, we will represent the complex number also, okay? Right. But it's just that we'll draw an arrow to there. That's what we'll do. Not necessarily representing the vector form, but yeah, there's no vector form attached to this, okay? So the Argand diagram, we will have the same as we have for the Cartesian plane, right? This one here is called our real axis here, okay? And this one here, sometimes they write it as yj. They write it as yj, imaginary axis, okay? And this comes from this representation of z is equal to x plus yj. And of course, this y is the imaginary component and x is the real component. Although we know that both x and y are real numbers, x and y are both real numbers, the elements of the real numbers in J still remains the square root of minus 1, okay? Doesn't change there. But now you can deal with the numbers as variables, okay? So in the Cartesian plane, sometimes some authors don't use this, the J part, they don't write it like that, they just write y. And some will put the stress there that this is the imaginary axis. So the vertical axis, the one going up and down, that's the that goes upward to a positive infinity and downward to negative infinity. That one is called the imaginary axis. Okay, it's called the imaginary axis. Right. So this one, sometimes they put the J there, sometimes they don't. And of course, the horizontal axis is the x-axis, that's the real axis. Okay. Of course, J is the square root of minus 1. So, but I see that your guys don't use that J in that. You must just remember that the vertical axis represents the imaginary numbers, okay? Right, or the imaginary part. So let's do this. Right. So for example, suppose I have numbers that I want to represent. Suppose I have a number, let's see, Z1, let's say Z1 is equal to 2 plus 3J, 2 plus J3 or 3J. And Z2 is the number, say, minus 3 plus 2J. They start with 1, 2, 3. Okay, they call this Z2, doesn't really matter, but it's fine. Let me stick to their way of writing it. Let's stick to their way of writing. So they refer to this as Z2, and this one is Z1. And so I just try to be consistent with them. So Z1, according to them, is minus 3 plus 2J or J2. And Z2 is 2 plus 3J, Z subscript 2, and Z subscript 3, that complex number, is given as 4 minus 3J, and Z4. So we'll try and represent these numbers on the Argand diagram now, right? And this one is minus 4, negative 5J. Okay, right. So of course the question here is very simple. Of course, in the first quadrant, remember the y part, the y represents that component, the second component, which is your imaginary part. The question is, in this first quadrant here, both x and y components are positive. In the second quadrant here, the Cartesian plane, here the y component is positive and the x component is negative. And here in the third quadrant, both of them are negative. Both the x, the real component, and the imaginary components are negative. And in the fourth quadrant, only the y component, the imaginary component, is negative, and the real component x is positive. Okay, right. So just bear that in mind. It's the same like as for the Cartesian plane, guys. Okay, the standard Cartesian plane where you deal with real numbers. It's just that y now represents the imaginary part. So let's represent z1. Well, we can see for z1 x is negative. Where is x negative? Well, x is negative in the second quadrant, and y is positive there. Right, that 2 is positive. So -3 will lie somewhere there, and 2 will lie somewhere there, say. Okay, just estimating. So that your point of interest is somewhere there. There's that number, there's that complex number line. I interpolate. I interpolate that. So there's that complex number. So they just draw an arrow to it. And then that issue of the length comes up of the number, the modulus of the number comes up. And so that A part there, that point A represents Z1. Okay. So that's your Z1, this one. Right? And then for Z2, let's consider Z2. Z2, X is positive, it's 2. The real part is positive. Also, the imaginary part 3 is positive, somewhere there. And then I can just interpolate. And look where my complex number is now. There about my complex number, and this is B. Right? So, and then I can just draw my arrow up to there. So this here is my Z. Let me just write here, this is Z1, the complex number Z1. This is the complex number Z2. And in the same way, we do complex number Z3. Let's do Z3 now. For Z3, the real part is positive 4. The real part is positive 4. And there's 4, say. And then the imaginary part is negative 3, say. And then we interpolate that. Interpolate that. And we end up with this point here. Somewhere there. Roughly there. That's our point. This is the complex number Z3. And again, we can draw that number. That arrow doesn't suggest direction, guys. Okay, it's just the way they draw it. There's nothing to do with vectors and stuff. Nothing like that. Okay, I don't prefer them writing it in that way with an arrow, but it's fine. So there's Z3 for you. With Z4, both the real and the imaginary parts are negative. So we'll be in quadrant number 3. So suppose -4 lies there. And what was this? This was -3. This one for that number. And say -5 lies somewhere there. Say -5 lies somewhere there. Then we can just interpolate. Right? So that we end up with this number. And this here, this dot here represents that complex number Z4. Right. So we have a way of representing a complex number so that we have some visual perspective of it. And we use the Argand diagram, whereby the y component, that vertical component, represents the imaginary part, and the real part is represented along the x-axis. Okay. Especially, you'll encounter in many instances they would write the complex number z as x plus yj, or x plus jy. Okay. And with the normal meanings, x and y are elements of the real numbers, j is the square root of -1. Right. That activity should be relatively easy for you guys now. There's an activity there, and it's called activity 4. I think now it's relatively easy after you've drawn those 4 complex numbers. I think it's easy for you now to draw, let's say, if you look at activity 4, let me just share your learning guide with you guys. Learning guide. Right. So they request you to do this, which I think is too easy for you. after this exercise, if you understand what I did. Let me just go to that activity 4. So there's that what I drew for you. And like I said, I don't like the arrow nature of it. It suggests something of a vector nature, which is not the case. It's just a complex number. So, and with activity 4, if you guys can see the learning guide 1, figure 1 there, page 94, they say represent the following complex numbers on an Argand diagram, right? You can see there A, that point A is minus 2 plus 3j, j3. There x is negative and y is positive. So that number A, the point A, or that number minus 2 plus 3j will lie in the second quadrant. And then for B, that will lie in the first quadrant. The real part is 4, the imaginary part is 2. And for C, well, in that part, you have y negative and x positive. So that will lie in the fourth quadrant, that one, okay? The C. So that should be relatively easy for you guys, okay? I don't anticipate you having serious troubles with that now. Those are some of the activities we did, guys. And then and the activities show you nicely. That's what I said. I said A lies in the third, I said A lies in the second quadrant, B lies in the first, and C in the fourth quadrant. Okay, so that's how we drew that. Of course, I don't like the arrow nature that you. So let's just sum up what they expect from you now, guys. So since you completed learning unit 1 on imaginary and complex numbers, and you should be able to, and you should be able to do the following: express an imaginary number in standard form, that's rectangular form. Find the complex conjugate of a complex number. Well, only the sign of the imaginary, only the sign of the part that's attached to the j that changes. Represent a complex number on the Argand diagram. We've just done that. We've solved, I think we've solved 2 quadratic equations, and we introduced the notion of j equal to the square root of -1. Okay. So what we'll do now, we'll go on to operations with complex numbers, addition, subtraction, multiplication, etc. Okay, and later when we introduce polar form and exponential forms, you'll see that it's much easier to handle, to do operations in complex numbers using those forms, okay? Exponential form, a polar form, rectangular forms, okay? So let's just sum up what's the expectations here, the outcomes at the end of this learning unit with operations with complex numbers. So on operations with complex numbers, you should be able to add, subtract, multiply, and divide complex numbers and solve complex equations, okay? So you'll see that it's relatively simple, okay? Let's just do some addition of complex numbers. Let me just share the whiteboard with you guys. Let's just check that, guys. The whiteboard. Right. Okay, so we're looking now at operations. So just write down, this is learning unit 2, module 4 still. So it's module 4, still module 4, and it's learning unit 2, okay? And this is called operations with complex numbers. So it's operations operations with or on complex numbers. Operations with complex numbers. Okay. Right. So let's consider addition of complex numbers, how that works. Let me just construct any 2 complex numbers and see how we do that. So I will not necessarily use their examples. I'll use my own examples here and there. So let's call this example 1. So suppose I tell you, let's call this example 1. They've got some other numbers, but I'll just change it. It doesn't matter really, okay? So they say simplify and write in the form A plus bj. So rectangular form or the standard form or the Cartesian form. Okay, that's what we call it. Rectangular form. So simplify and write it in the Cartesian form or the rectangular form. So okay. Suppose I tell you, I give you complex numbers. Suppose my complex numbers are -7, -3j, plus, I'm doing addition now, plus -4, plus 2j. I want you to add those, and now I want you to subtract these ones. So the same two numbers, I want subtraction on them now. The same two numbers, now I want you to subtract them and see what happens now. Let's look at the A part. Let's look at the A part there, guys. Okay. So we have the same two complex numbers, -3 -3j, -7 -3j, and -4 plus 2j. First, I request you to add them. So remember, guys, when I do addition or subtraction for that matter, I will be combining the real parts with the real parts. So for the A part, for the A question, example, this is my own example one, and maybe I should just call it example. It's not the book's example, the guide's example. I just call it example. So the two real parts here are this. I'm adding them. And the imaginary parts, well, it's -3j plus 2j minus j. Okay. So that's, I combine these two, we got minus j. Again, now I'm doing subtraction. So -7 minus -4 is the same as -7 plus 4, which is -3. And now I look at -3j and 2j, I subtract -3j minus 2j minus 5j. Right? So you just look at those things. Oh, let me just put the bracket here, guys. Sorry, put the bracket. So you had -3j minus 2j. So it's minus 5j. And then you had -7 minus -4, which gives you -3. So there are your two complex numbers. -11 minus j and -3 minus 5j. So let me stop and just check if there are any questions for clarification, guys. Okay. Okay, people seem to be fine with that. Relatively simple. And then you guys can look at it, activity 1 there, but let's do the C part. Let's do the C part quickly. For activity 1 on page 99, right? In the absence of questions, let's proceed with the whiteboard, and let's see that. So in your learning guide, it's on page 99. Why am I having problems with the pen? Let's see. So in your learning guide, guys, it's okay. Where am I now? Sorry, guys, I'm just adjusting this thing again. I sorted out the drivers yesterday. I hope my settings of the pen was fine. I'm not able to locate where it is now. Okay, hang on for me, guys. I just want us to proceed with okay. Let me just exit the whiteboard quickly, guys, and come back to it. Let me just exit the whiteboard and come back. Let me just stop sharing that. And then just see. Just let me just share the learning guide with you in the meantime. Let me just deal with that whiteboard. Okay. Okay. Yeah, can we create a new whiteboard? Doesn't matter really. New whiteboard there. Okay, just see. Yeah, that's fine. Okay, fine. Well, you still have it there. So let me just share a new whiteboard with you guys. New whiteboard with you. Right. Okay. Hope you guys can see the new whiteboard. Okay, right. So activity 1 asks you to activity 1. So in particular, I'm looking particularly at problem number C there. Okay. I'm looking at number C. Right, let's see quickly. Just looking at problem number C quickly, guys. Let's see. Okay, so for problem number C, it asks you to find the following sum. It's -4 plus 3j. There's nothing spectacular about it. It's just the fact that they have a cert there. So I said, okay, I didn't put a cert for my construction of my example. And there's a look at that one, guys. Okay, we know how to deal with that. There's nothing extraordinary about it. The only thing, if someone probably forgot how to deal with the square root of -4, they'll probably end up in trouble with that. But otherwise, it's no problem. Okay, let's see quickly. Let's just try and sort out. In the meantime, we can sort out the real part. Okay, this poses no problem. -4 minus 1 is -5 plus 3j. And then the part that we want to consider now is this part here, minus there's that minus, there's the square root of -1, and there's the square root of 4. Okay, so so we have -5, we added -4 and -1, right? This is plus minus, okay? This is plus minus, so it's minus. This is j here, and this is 2. Square root of 4 is 2, right? So if you guys are fine with that, then I look at my imaginary parts again. So I keep my real part, and I've got 3j minus 2j, which gives me j. So that's how you reduce that one, activity 4. You guys can just refer maybe to responses there on it. But that's how I would approach that one. It's activity 2. It's activity 1, sorry guys, activity 1, page 99. Just see there, activity 1. Yeah, it's number C, okay? -5 plus j, yeah, that seems fine. So when you're given such a problem, guys, just remember, you know how to deal with the square root of -4. You know how to deal with all these minuses. So I firstly settle the case for -4, -1, which is -5 with real parts. I wrote it down, and then I said, let me break up square root of -4 into j and 2. And that's what I get, okay? Right. So I just want to check if there are any questions before we go on to multiplication of complex numbers, guys. There's a request that I start again. Okay, I suspect with that problem, né? That problem. Okay, let me just try and just reiterate that, because I know it can be a bit confusing. So let me just deal with the same problem quickly, okay? So let me just see my pen. Okay, C again. C again. All right, let's just see. Okay, so guys, let's just go back to C again, okay? Just say C again. Okay, so let me start slowly. So C again. So we do that again. So they asked us to add these two complex numbers, -4 plus 3j. -1 minus square root of -1. Square root of -4, sorry. So I think the request was maybe just to explain that again. Okay, not necessarily start again, but it's fine. So let's see quickly. So just for the benefit of others who are also lost. So what I looked at, I said, okay, this one here, I know I can write this as square root of -1 times the square root of 4. And we know the square root of -1 is j, and the square root of 4 is 2. It's 2j. Okay, so you can do it straight away and change those things before you even add. You can first maybe say, okay, I'm not going to add until I write that in the standard form, until I write the second bracket in standard form. So someone might say, no, I'm not going to add the reals now. I'm going to say -4, -1. I'm just going to sort out the second bracket first, okay? Minus, so there's j. Right? So the person might start like that, which is nothing, it's nothing wrong with that. Right. Plus, so this is -1, minus, and this is j here, and this is 2, so it's 2j. Right, let's see. Now we have the reals with the reals. So when I write this nicely, it's -4 plus 3j, -1 minus 2j. Okay. Now I add the reals with the reals, and imaginary parts with the imaginary parts. Okay. So I get j. So that was that took a bit longer, but we end up with the same result. Just one step longer, but we end up with the same result. Okay. Right. So yeah. I trust that settles that, guys. I think whoever was lost should be found now. Okay. Right. Well, you guys, if that's sufficiently clear, we can proceed to multiplication of complex numbers. Just a word of caution, guys. Remember that j squared is equal to -1. We've established that now, right? We have established that. I've stressed some things in the last session we had. So let's look at complex numbers. Let's look at the example 2 on page 99. It falls under the subsection multiplication. Okay, multiplication of complex numbers. So it's a subsection. So our first subsection was subsection 1, addition and subtraction. Now we look at multiplication. I hope I called it like that. Let me just see if I gave you that name, addition. Oh, and the other, okay, sure. I probably call it like that in the other board, on the other board, right? That's fine. So yeah, so there we entertained addition and subtraction. Now we're going to multiplication. Multiplication of complex numbers. Right? So let's see what happens there. So here, note that j squared equals to -1. J squared equals to -1. So in their example 2 on page 99, they have the following. They have the following case. They say simplify and then they multiply these two complex numbers. 3 plus 2j or j2, and 4 minus 5j. You'll see that the guide uses j5, j2. I prefer to write it as 2j minus. There's nothing wrong with that, okay? So if I multiply now, guys, and you guys have encountered how I did this at some stage, with a plus bj and a minus bj, I did multiplication for you then. It's the same process, that with that, that with that, that with that, and that with that. Okay. So I multiply 3 with 4, 3 with minus 5j, 2j with 4, and 2j with minus 5j. And we remember, sorry, the j squared, not j squared is minus 1. J is the square root of minus 1. Sorry, the correction there, guys. I said something and I wrote something else. Okay, so 3 times 4 is 12. And 3 times negative 5 is negative 15. And then there's a j part. And then we do 2j. 2j times 4 is 8j. And 2 times negative 5 is negative 10. And j times j is j squared. So now that's fine. We have that. We can add up our j's there. We have 12. Minus 15j plus 8j is minus 7j. Minus 10 times j squared is minus 1. Okay. So j squared is minus 1. So we've got 10. So this gives me 10. Minus 10 times minus 1 gives me 10. And that is 22 minus 7j. There's my multiplication, where I multiply a rectangular with another rectangular form. Okay. Let me just see if you guys are fine with that. And then we can do 1 or 2 more problems. Oh, j squared, just j. Okay. There was a question from student Amelia on the note j. Oh, j squared. Okay. Thanks, Amelia. I see your note now. On the note j, it should be j squared equal to minus 1. Thanks for that. Okay. Sorry, I saw that now, but I think I corrected it. Huh? She's referring. Student Amelia is referring to this here. Initially, I wrote j equal to minus 1. Very wrong. Okay. Right. Okay, great. Let's look at the activity 2 there, guys. If there are no further questions, let's look at the activity 2. And it's so with activity 2 on page 100, it deals with multiplication, and but what we've done is sufficient already. What we've done already, it's sufficient for your understanding. So I want us to look at activity 2, and then you guys can see what we've done thus far. Okay. Activity 2. Right. So we've looked at activity 1. We did some problems there. In fact, we did number C, I think, because we understood the others by now, based on the examples I constructed. We just did this multiplication, taking cognizance of the fact that j squared is equal to minus 1. Look at activity 2. You can see there's nothing fantastic here. But I think a very interesting problem to do would be maybe to look at number B, C. Number D we've done together. And when we did number D, when I started off with the Z times its conjugate, if you look at number D there, you'll see A plus BJ multiplied by A minus BJ. So those are two conjugates that are multiplied. And you will recall that when I multiplied those numbers for you, we got Z times its conjugate gives us A squared plus B squared. Okay. And it's a very important product that it yielded. And you will see now that the case C is a special case of that, because you have 7 plus 3j and 7 minus 3j. So our answer already, we know that answer should be 7 squared plus 3 squared. Okay, so our answer should be 49 plus 9, which is 58 already, just by looking at number C, because we know the result of number D. So what I'm going to do, I'm going to write down activity 2 and just make a note on it also, right? So, and then we can do 1 or 2 problems there, okay, before we move on to division. So I think for activity 2 that you saw now, I will skip some stuff. There's a B question there. 5 plus 3j. So multiply. So the question is multiply and write the answer. And write your answer Sorry guys. Multiply and write your answer in the form in the rectangular form a plus bj. Okay, so here we've got for the b part of activity 2, we have 5 plus 3j squared, all squared, sorry, all squared. And then I want to look at the c part. But before I look at the c part, let me write down the d part. Let me write down the d part quickly. The d part is something which we encountered, like I said. We've done this multiplication already when we started off. I multiplied z with its conjugate, where z was a plus bj and the conjugate was a minus bj. And we got here a squared plus b squared. And then I even said to you, this is the, the modulus squared of a complex number, the length of a complex number squared, okay? So this one we have already from a previous encounter. So the C part, the C part's answer is therefore obvious, and we will confirm that. There for the C part, so you might think I'm just rearranging stuff, but I think they should have written for the D part should be C and C should be D. Okay. And this is 7 minus 3j, unless they wanted you to see a specific problem and then generalize it. Okay, that's also fine. That's also fine. So I expect this answer based on what I have here and here and here. A squared is 7 squared. And these are two conjugates. A plus bj and a minus bj are conjugates. 7 plus 3j and 7 minus 3j are conjugates. So this answer immediately I can say is that, which is 49 plus 9, which is 58. We will verify that, okay? So let me write here a note to check. This was done already. Let's do number B and then we'll check number C, okay? Let's do B and check and then we'll check number C. Right. So let's do B. Well, for B, the fact that you see, you can write this, you can, when the exponent is a 2, you can just say 5 squared plus that 2 times 5 times 3j. When the exponent is a 2, and then you can just say 3j squared. Okay. If the exponent is greater than 2, you can't do what I'm doing now. Okay. So it's a bit like when you did a plus b squared. You did like a plus b squared. You just said, there guys, you just said a squared plus 2ab plus b squared. You know, in grade 8 somewhere they used to do that kind of stuff. Okay. So so that's only in the case where the exponent is a 2. Anything greater than that, well, you have to be more creative than that. Okay. So let's see this answer. Or someone could have just written it out, 5 plus 3j times 5 plus 3j. Okay. Let's see what this yields. It was 25 plus 30j plus 9j squared. Right? So when we do that, we've got 25 plus 10j. J squared is minus 1, so we've got that. And 25 minus 9 is 16 plus 10j. Okay. So that's that part. You guys must just double check.
It's actually 30j.
30j. Oh, I just saw it out. 2 times 5 times 3. So I forgot about the 3, right? Thanks. Guys, here you reminded me. I just said 2 times 5. I forgot this 3. It's 30. Thanks. Because I thought something wasn't right here. Thanks for that. Let me just go there. This should be 30j, guys. Thanks. My next question was, did you guys check my calculations? 30j, no? Right. I think everything else seems fine from where I'm standing. Now I have to change that part. So it's but that's fine, and it's just 30J. I think it should be okay now. Just double check again, guys. Because 5 squared is 25. 2 times 5 times 3 is 30J plus. So minus 9, because J squared is minus 1. 3 times 3 is 9. 25 minus 9 is 16. Yeah, seems fine. Okay, guys, so there's it, right? So I don't think you guys should have problems with that, right? Now, let us verify the answer for C. Let us see indeed if I'm correct. We said we have to check this. Let's check it quickly now. So I said the answer must be exactly 58 based on the D result that we got earlier. Okay, so let's do C quickly and see if we got that answer 58. C. Right, let's write down C. So C asks you to multiply these two complex numbers. Right? Let's take our time now multiplying it out. 7 times 7 is 49. 7 times minus 3J is minus 21J. And now we use the 3J. We multiply 3J with the terms in the second bracket now. Plus 21J. Then we multiply 3J by minus 3J. So we've got minus 9J squared. Right? There's a cancellation of the middle terms as expected. We have 49. Remember, J squared is minus 1, so we have plus 9. J squared is minus 1, so we've got that. And again, as expected, 58 is our answer. Okay. So, but just by looking at it, because of this result in D, this result here is a generalization of C. Okay. That's all, guys. Okay. And so that's so much. So for multiplication. So any questions for clarification before we proceed to division, guys? Then we would have done all the operations on complex numbers. And then we can maybe look at maybe 2 examples and an activity of 2 problems or 3 problems. I think that's, yeah, before we start with complex equations, okay? Perhaps we can do complex equations when we meet again, and then do Poland exponential. And then hopefully, yeah, we won't spend more than 2 weeks on those. Okay, great. Okay, there's a question. There's a question. Right. Okay, student, you can go ahead.
Hello, sir.
Hi, hi.
When I'm looking at a plus bj multiplied by a minus bj,
Yeah.
I don't get why it's a squared plus b squared and not a squared minus b squared.
Oh, you don't get that. Okay.
Yeah.
Were you here at the start of the facilitation session? Were you here at the start?
No, I missed 10 minutes.
Okay. Oh, because I've already explained this problem.
Okay.
I have explained it, but I mean, if people are fine, I can explain it again. This D, she just requested if you guys are patient enough, I can go through the D part again and explain that, because this is the part I sort of start off virtually with this part. Okay, I started off the session. Okay.
Yes, I'm sorry for that.
You're saying?
No, I'm saying I'm sorry I missed that part. So.
Okay, no, it's fine. Let me, because we had specific names for these things, and then I tried to also introduce them to a result earlier,
Okay.
and in anticipation of some of these other things. But it's okay if other people are fine. Let me just explain D again, because you see what I did was I first started with the complex number a plus bj
Yes.
in Cartesian form, right?
Yes.
I first started with that. And then I said the conjugate of this number, which we denote as z bar, can be written as a minus bj. Sorry, let me just take that bracket away. So then I said z bar is called the conjugate of a complex number. Then I said it's a minus bj, right? Then I said, let's multiply the 2 numbers and let's see what we get. So I said, look, if you say z conjugate, and this multiplication is commutative, Z bar is the same as Z times Z bar. Z bar times Z is the same as Z times Z bar, and vice versa. Okay. So then I said, okay,
Yes.
let's multiply then. A plus BJ. So I'm multiplying what I call two conjugates. Okay, we call them conjugates.
Yes.
And then we said, okay, let's take our time. And then I said, okay, so A will be multiplied by A will be multiplied by minus BJ, BJ will be multiplied by A, and BJ will multiply by minus BJ. Okay,
Yes.
so A times A is A squared, right?
Yes.
And then A times negative BJ in the second bracket, the second term of the second bracket.
Yes.
So it's minus ABJ, right? So we're done with the A in the first bracket now. So we've used all the terms in the second bracket, right? Now I use BJ in the first bracket and I multiply it with the two terms in the second bracket. So BJ times A, BJ times A is ABJ again.
Yes.
Right? Remember, A times B is B times A, right?
Yes.
And now, lastly, I multiply BJ with minus BJ. So I get minus B squared, J squared. But J squared is minus 1, right?
Oh.
And
Yes.
this cancels. And hence you end up with what we wrote down there. Okay, great. I'm happy you understand that. That allowed me to preempt based on this preliminary result that I wrote down at the onset of the facilitation session. This allowed me to predict the result for C. Okay, that's why, because I know a number Z multiplied by its conjugate just gives me the real part squared plus the imaginary part squared. So hence I can do that. Okay, great. Okay, guys. So thanks, but thanks for allowing me to reiterate that point. It's important that. Okay, so okay, there don't seem to be any other questions, guys. What we'll do now, we'll do an activity on. So we'll start with division. I'll explain it. And then, so I have some preliminary explanation, and we go to 1 or 2 examples. Okay, and then we do an activity. And trying to do that activity as fast as possible. We do it completely. Okay. At least 80% of that activity. It's fine. Let's see if we can do that. We still have 15, 16 minutes left. Let's see quickly. So this subsection of operations on complex or with complex numbers is called division. So we know we've dealt with addition, subtraction, and multiplication, and you could see it's not that challenging, really, if you stick to the basic rules. So division of complex numbers. Okay, so the point here is, guys, you'll have a fraction because you're dividing one number by another, so you have a fraction automatically. But what you must do, you must multiply that fraction. You must multiply it with the complex conjugate of the denominator. And that complex conjugate must appear in the numerator and the denominator. Okay, so I'll show you what I mean with that statement. So with division. So for example, and they call it example 3 on page 100, okay? Example 3 on page 100. Right, let's see quickly. And it's the A part. Sorry, the A part. So example 3 is with a number of sub-questions. Let's do 2 of those questions at least, okay? 2 of those questions will be fine. And we can go back to the activity quickly and maybe trying to do 80% if possible. So the first question says, so example 3 says divide. So let me just write down the question for the benefit of others who may not have the guides. Divide. I would prefer it if you guys have your guides open in front of you and follow. It's easier like that. Then I don't need to write down the question every time. Divide and express. Divide and express. Oh, that's not written so nicely. Sorry for that, guys. divide and express each answer in the form a plus bj. Right. So whatever you have, when you have a fraction, as we will encounter now, you must write that answer in the form a plus bj in the rectangular Cartesian form. So their first question was, write this in the form a plus bj. So there's a complex number divided by another complex number. Now I started off by saying, to do this multiplication, you must multiply, you must consider this denominator. And what you do is you multiply now, you multiply that with the complex conjugate of the denominator in the numerator and the denominator. Because basically what you've done, you've introduced multiplication by 1. Because I minus j divided by I minus j is just equal to 1. And any number multiplied by 1 is just that number. So I haven't changed anything really. The only thing I did was I took care of the multiplication by the complex conjugate of the denominator, both in the numerator and in the denominator. Remember the complex conjugate of this, is 1 minus j, okay? That's how we discuss complex conjugates. Put this back again. And that is the secret. Once you remember that step, okay, to deal with such a case, always multiply on the right-hand side with the complex conjugate in the numerator and the denominator, but it must be the complex conjugate of the denominator, okay? Right. So, because we have some prior effects of complex conjugate multiplication, we know that a minus bj times a plus bj is a squared plus b squared. So I don't expect there to be a problem when we write down the denominator's answer. Can anyone tell me what is the answer here in the denominator based on the result that we encountered in D? In D, we said that, let me just take away these sticks here, guys. In D, we said that a plus bj times a minus bj, so those ones are conjugates. When you multiply a complex number with its conjugate, you just say the real part squared plus the complex part squared plus the imaginary part squared. That's all. So look at I plus j times I minus j in the denominator there. Okay. Let me just see the chat quickly, guys. Did you see the chat? Okay. Okay, I don't agree with the response I got. I don't agree with the response I got there. Okay, there's another. Okay, I don't know what's first now. Can I maybe ask student Joyce, maybe? Student Joyce, okay?
Yes, on the denominator, j will cancel j, and then my denominator will be 1 plus 1, which will be 2.
Okay, so it will be 1 squared plus minus 1 squared, right? 1 squared plus minus 1 squared, right? Basically, that's what you're saying. Of course, you are right when you say that. But I'm saying if you look at it quickly, a plus j, a minus bj is a squared plus b squared. So it's 1 squared plus minus 1 squared equal to 2. I think I hope everyone can see that, guys. Joyce did it the long way, but it's fine. It's 2. I think everyone should agree with that, okay? There's still a hand. Joyce, is that an old hand of yours? Is that an old hand? Okay. Then there's another end of an unknown person.
That's me. Let me just agree with Joyce. I wanted to give the answer.
Great. Yeah. Great. Okay. Okay, great. There's still an end that's up, so I'm not sure.
Franz, student Franz, ask your question, please.
Yes, good day. So I thought the doctor was asking about the denominator, so I just wanted to give a sort of an explanation.
Yes. You can still provide
formula.
Yeah, you can still provide it. You can still provide it.
Okay, so looking at the outcome of the above, which is a the conjugate
let me just scroll up there, Franz. Let me just scroll.
Yeah.
Okay. Yeah. Okay.
So we know that yes, that is in D. We know that when you multiply a conjugate of that number, you get a squared plus b squared. So in that case, can you just scroll down a bit?
Okay.
So we know that. So the denominator, it's actually a multiplication of a conjugate. So we get 1 squared. So j will cancel a j, and then we get a minus j squared. But we know that j squared is a minus 1. So that becomes ultimately 1 plus 1.
Good. It's 1 squared plus minus 1 squared, which is 1 plus 1 is 2. Good. It's just a quick way. That's hence I wrote it down. Okay. Great. Thanks, Franz. Thanks for that. Great. Let's look at the numerator, guys. The numerator should be relatively easy for you guys. When you multiply that out, let's just do it for the sake of everyone. So 10 times 1 is 10, right? And 10 times minus j is minus 10j. And minus 4j times 1 is minus 4j. And then minus 4j times minus j, well, minus 4 times minus 1 is plus. And then we have j squared. Okay. So let's extend those guys. Okay. So I said 10 times 1 is 10. 10 times minus j is minus 10j. Minus 4j times 1 is minus 4j. And now the last one, minus 4j. So it's minus 4 times minus 1 is 4, and j times j is j squared. But j squared is equal to minus 1. Right? So just be aware of that. And then we'll have 10 minus 4, which is 6, and minus 14j. So this part here becomes minus 4. The whole thing becomes minus 4 because j squared is minus 1. So 10 minus 4, it's 6. Okay? 10 minus 4 is 6. Right? And then minus 10j minus 4j is minus 14j divided by 2, which we can write down as 3 minus 7j. Okay. Yeah. And that's in the required form a plus bj. Okay, where my a is 3 and my b is minus 7. Okay. Right. So we've just done, we know how to do multiplication. We've covered multiplication. Now we come to division, but you will see with division, it's important to know what is a conjugate, and in particular the denominator. Okay, because we multiplied on the right by the conjugate of the denominator. We multiplied by the numerator, which was the conjugate of the denominator, and by the denominator, by the denominator's conjugate also in the denominator. Okay, because we multiply by 1 basically. We haven't changed anything really. It's the same concept, same answer. Okay, because any number multiplied by 1, that number remains unchanged. So we have equality. Let me just select another problem there, guys. Let's select number Let me select number D there from example 3. So I want to select number D, and before I was hoping we could get to the activity quickly. So for number D, they also say divide and express each answer in the form A plus BJ. That one says 0,5 plus square root of 3J, all divided by 2.4J. Right. So that's where we are. Of course, B and C look they look exactly like A. Okay. D looks a bit different, but ultimately it's the same principle. Okay. So I want to know from you guys now, what will I multiply here on top with? And what will I multiply here on the bottom with? Let me just do this, guys. Can anyone venture an answer there, guys? What must I multiply with in the denominator and what must I multiply with in the numerator? Okay, the student Emilia. Okay, Emilia?
Yes, I just want to know, since in the previous example, we were just multiplying by 1, but as a conjugate. In this
Yes.
case, can't you just use 2.4J?
But what is the conjugate of 2.4J? What is the conjugate of it?
Ooh, skip.
Minus 2.4J.
Right. Né? Look, what you're saying is correct, actually. What you're saying is also, you can just multiply by 2.4J and then it's done, you know? Because you can test it, just a negative will arise, that's all. The other one will be positive. I hope you can see that, okay? So there's no harm in multiplying, like she said, guys, with number D. There's no harm in it if you multiply by 2.4 straight away. There's no harm in it really, because J times J is minus 1, okay? So, but of course, if we stick, just not to forget, in other cases, we know that the conjugate of the denominator is minus 2.4J. Someone can try it just with 2.4J. Someone can try it maybe just with 2.4J. They should get the same answer. They'll just rework it a bit. Okay. Right. So what will our answer in the denominator be? But you see, the thing was of the multiplying by the conjugate, then we don't have negatives there, you see? Then we don't have negatives in the denominator. So that's why we prefer to multiply by the conjugate. So then because you will still end up with a negative there, okay? Right. So what is this answer equal to, guys? Remember, J times J is J squared. J squared is minus 1 times that minus in front of the 2.4. So it's plus 1. So what is 2.4 times 2.4?
4.8.
I corner.
5.76.
2.4 5.76.
Yes.
5.76. So there's the minus. There's J times J, and someone said 5.76. I mean, I know 24 times 24 is 576, right? So 2.4 times 2.4 must be that. So let's do the multiplication on top, guys. Let me just extend this line here. If you guys are happy with that result at the bottom. And you can see that there will be a positive in the denominator, okay? Because J squared is minus 1 times minus 1 is 1, okay? So already here you can see this thing here is equal to 1, okay? So there'll be a positive there. Let's multiply out now. The rest are quite simple. So 0.5 times that second bracket gives us on top. What is half of that? Minus 1.2. J. minus, what is square root of 3 times minus 2.4, guys? What is square root of 3 times 2.4, guys? Okay, I'm just going to round it off roughly, right? It's 4, because I know the square root of 3 is about 1.73, guys, right? So, but it's not an accurate answer. So use your calculators, then just round off to two decimal places, I think. So it's 1.6, roughly 1.6. And it's j squared, right? Right, correct. I don't know how they give the answer in the activity. We'll check now. Because I normally prefer people to leave the cert as it is, don't interfere with it, but it's fine. So if the multiplication is correct on top, if it's correct, then j squared is minus 1. Minus 1 times minus 1 is plus 1. So I've got 4.16 minus 1.2. Right? And then in the denominator, we said, oh, but I missed something here, 1.2 j, no? J, no. 1.2 j. I want you guys to double check my stuff there, guys. 5.76. Right? Actually, you should leave your answer, you should round off, the final answer should be rounded off, okay? The final answer should be rounded off. I rounded off too early on top. I should have kept that and then divide. So, but let me just see what I have. If I keep it, so I divide it by 5.76. Okay. So I get, and you guys can confirm, guys. I get when I divide every number, if I divided complex number right through by 5.76, when I work more accurately, I get roughly. So I would normally do this nearly equal to, because I've rounded off, I would say nearly equal to 0.72 minus, then I would say 1.2 divided by 5.76. And I get about 0.21 j. I don't know how the book will look at the book's answer now, guys. 0.21 j. Okay. All right. Let me just see the book's answer. I hope you guys know what I did there. I just said j squared is minus 1 times minus 1 is plus 1. And there's my 1.2 j, right? But remember, we multiplied minus 2.4 by the square root of 3. And the square root of 3 is about 1.73, blah, 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 blah. So I keep all those digits in my calculator. And then my final answer is roughly equal to 0.72. It's my real part. My imaginary part is minus 0.21. I just want to see what they have there. What activity was, what example was this? This was example 3D. What was this? Oh, yes, now they got it exactly like that. So the trick is, guys, keep everything in your calculator as far as possible and then round off maybe to 2 decimals, okay? So, and then the answer is nearly equal to that. That's nearly equal to, okay? Right. So I want us to go to an activity now. So there's a question from student Emilia. Okay. Is that, Emilia, is that an old end?
Yes, that's an old end.
Okay, no problem. I think it's just a matter of calculation now. That's not such a big deal, okay? I just want you guys to understand the principles here, okay? And I've kept all the digits. Though I rounded off here, I remembered that this square root of 3, it's not a recurring decimal, okay? It's not a recurring decimal because it's an irrational number, okay? It's an algebraic number, but it's irrational. So I keep all the digits in my calculator and then I do them all. And then I round off the final answer. And then I've got an answer nearly equal to 0.72 minus 0.21J, okay? Which is in the required form that they wanted. So now, guys, for the rest of the time, I want us to look at activity 3 now. And let's try and do and let me just show you activity 3 quickly. Let me share the screen with you. So I want us to look at, this is what I want us to look at. If you guys can't see it, let me just go there quickly, activity 3. Activity 3. Okay, I hope you guys can see activity 3 there. I hope you guys can see activity 3.
Yes, we can.
Great. Okay, great stuff. Okay, so so what we'll do is we'll do a number of tricks here and there, and some of it relies on your memory from school, okay, and memory in terms of what we did now. I do not expect you guys to have serious challenges regarding the A4 minus 3I. People here, the I denotes J, okay? Just a correction there, guys. In engineering, usually you guys prefer to write J instead of I. The I is normally employed in pure mathematics, standing for imaginary, okay? But because you guys also deal with currents, if you do electrical engineering, you also deal with currents and you use that notation I for current. So hence, the engineering guys prefer to use J, but here J and I happen to mean the same thing, okay? They mean the same thing exactly. So I is the square root of -1, which is like J.
Dr. CS,
Okay,
I just
great.
want to find out the hand that is raised. Student, is that historical or do you have a question? Student Amelia, you have a question?
I suspect she mentioned that it was accidental.
Yes,
Oh, it's
I'm
not
sorry
going
for
down.
that. I only raised 2 times and
Okay, no problem.
There we go.
Okay, great. Thanks for that. Great. So, can you guys still see the screen, I guess, for activity 3? Okay, great. So,
Oh, sorry, yes, we can see it.
okay, great. So if that's the case, that's fine. I'm happy. So I do not anticipate you guys having serious impediments to solve activity 3A, because what you will do there is, again, you will multiply on the right-hand side by 7 minus 2I over 7 minus 2I. Remember here, guys, I and J mean the same thing here, square root of -1, okay? It's just that you guys prefer to use J, because I use for currents, like I said. We will do the B part together. Let's try and resolve the B part, which is not difficult. We'll have the same approach, because there we've got 3 terms now. So for all of those 3 terms, we'll multiply by the conjugate. The first one, conjugate of the denominator on both sides, both top and bottom. For the second one, multiply by the conjugate of the denominator, top and bottom, and the same for 7 over 1 minus I. None of them pose a serious problem. D may be a bit tricky, but it's not. Even C. Let's look at B quickly, okay? Let's look at B. So what I'm going to do, guys, instead of writing I, I'm going to write J, okay? J meaning the same thing as I, okay? Right. So let's look at activity 3 now. Okay, great. So activity 3. Right. So I will say the A easy. Say easy. Right. Let's look at the B part. You just make a note here. I is the same as J. Okay? I means the same thing as J. Okay, right. So I'm going to write down B as. So I'm going to write B as 1 over 1 plus J minus 3 over 2 minus J plus 7 divided by 1 minus J. Right? Let me just check if I wrote it down correctly. Good. Okay, yes. Right. This is equal to this is equal to 1 over 1 plus J multiplied by 1 minus J over 1 minus J minus 3 over 2 minus J multiplied by 2 plus J over 2 plus J conjugate. Over 2 plus J. Right. Then the last term, the third term there, 7 over. It's 1 minus J. I will multiply it by the conjugate on top and at the bottom. 1 plus J and 1 plus J. Right. Now we know that A minus BJ times A plus BJ is A squared plus B squared. Okay. We know that already. So I don't expect any problems from you guys when I write down that answer. Okay. Right. When I write down the answers for the denominators in those 3 terms, I don't anticipate you guys having problems. And I will put here A plus BJ multiplied by, so the Z times its conjugate is equal to A squared plus B squared. So it's the real part squared plus the imaginary part squared. Okay. Sorry, let me just say that again. The real part squared, the 2 real parts. So it's the real part times the other real part. So the real part squared plus the square of the imaginary part. Okay. Right. So what do I have here? So on top, I've got 1 minus J. I think that's clear. In the denominator, I've got 1 squared plus 1 squared, which is 2. Right? Minus. Now, I must keep that minus in mind, but it's fine. So I've got 6. I keep that minus outside. I've got 6 plus 3J. I keep the minus outside for now. Divide by. Now, in my denominator there, I've got 2. So it's 2 squared plus 1 squared. It's A squared plus B squared. It's 2 squared plus 1 squared. It's 4 plus 1 is 5. Now I've got 7 plus 7j. And now I've got 1 squared plus 1 squared, which is 2 again. So this is what I end up with. I can add these two now if I want to. I can add those two. 2. Then I just add the denominators now. 1 plus 7 is 8. Minus 7 minus j plus 7j is 6j. 7j minus j is 6j. And now I can deal with my minus here and multiply inside. Right? Multiply that minus by those things there. So I've got minus 6 over 5. Minus 6 over 5. And I've got minus 3 over 5j. Right. So now I can then simplify that fraction over 2. I can divide every term by 2 there. So 8 divided by 2 is 4. And 6 divided by 2 is 3. So I've got 3j. Minus 1 and 1/5, which is 6 minus 6 over 5. Minus 3 over 5j. Right. Now, all I do is, guys, I add these two. And I add these two. So when I do that, well, what do I have there? So it's minus 1 and 1/5. So it's 3 and 4/5, is it not? 2 and 4/5. 2 and 4/5. You guys must just double check what I'm doing again. I don't like using a calculator for these things. 2 and 4/5 plus 1 and 1/5. But I'll write it nicely. 2 and 4/5, so it's 14 over 5. Okay. So it's just a matter of adding the fractions now, guys. Just a matter of adding the fractions, okay? So it's 14 over 5. And then, then I look at the j parts there. I've got, it's minus now, right? So it's minus. So it's 12 over 5. Double check for you guys. 15 over, what is that? 5 over 5, 12 over 5, huh? 12 over 5j. Guys, you must just double check my work, okay? 12 over 5j. Right. We can just compare the answers maybe in the learning guide from activity, there was B, né? Activity 3B. So my final answer, the main thing there, guys, was you must multiply each of those terms on the top and the bottom by the complex conjugate of the denominator, which is what I've done. And then every time I use the result in the far right corner here, I use this result. I just do it in my head, okay? And then I look at like terms, I add like terms. I divided 2 into 8, I got 4, 2 into 6, 3. And then I just add like terms, constants, reals, the real side with the real side, and the imaginary side with the imaginary side. So if I was correct, it's 15/5, so it's 12/5. J, and then that, yeah. So it's 14/5. Seems right, yeah. You guys, any questions there? Any questions there, guys? Let me just check. It's activity 3, number B. Activity 3, number B. Where is that? They've got guys, it appears as we made. Oh, okay. Oh, they do it very long. Yeah, they seem to be in agreement with our answer, guys. No? Yeah, they just do it very long, but it's fine. It's okay. They're very elaborate, and then they find I just do it in one line, okay? But it's okay. It's the same result. Anyone needed clarification on that, guys? Maybe I can just put you on the track for the next one, and then we can stop there. So the one I would also look, if there are no questions, guys, the other activity I would like to look at, the other question from the activity I would like to look at is this one here. Let me just share the guide with you guys, study guide. I would like us to look at number, if you guys can see the guide, I would like us to look at number C quickly. Number C. Okay. That's the one, yeah. Number C is fine. It's not so bad. It's actually all right. So I want us to look at number C quickly. And then maybe you guys can look at number D, and then we'll look at number D together, how you would approach it, okay? Of course, with number D, I would first suggest that you write 1 plus 2i, or 1 plus 2j is 1 plus 2i times, you're squaring that thing, so it's 1 plus 2. Okay, I think it's a bit awkward, this one, but it's fine, it's not so bad. You can probably first multiply it out, write it in the form a plus bj, get a complex conjugate, and then do the multiplication. Yes, I would propose that for that one. Let's look at number C there quickly. Let me share the whiteboard with you guys for number C. I'll try and be quick with this one. I see my pen is acting up again, so let's see. Let's check quickly, guys. So I trust that you guys can see the whiteboard there. So let's see quickly. So for the same activity, number C, so you have to write that, where is that? So you have to write it in the form a plus bj, okay? So I use j instead of I. I use j instead of I, okay? Right. So escape from it. Okay, guys, can you hear me? Oh, can you guys hear me there?
Yes, we can.
Okay, I'm just trying to sort out the whiteboard again. I don't know how the 5 disappeared. I think it was accidental. Oh, everything's disappearing now. Oh, guys, that part was not supposed to disappear. Okay. I wanted to erase some stuff on the screen. I think the whole thing, but I can undo it, right? Okay. Let's just see. So, I think the final answer, everything was fine here. I think the final answer is still correct. I don't know. There was an accidentally erased. There was accidentally erased. Okay. But what did we get? 14 over? I think it was 14 over 5.
Over 5.
Yeah, I just want to check what was the answer we got again. I don't know, I accidentally erased it now.
14 over 5 minus 12 over 5J.
Minus 12 over 5, no? Sorry,
Yes.
so it's not like I said it was wrong. I was just, I don't know. I wanted to raise something else. 14 over 5. And you said, plus?
Minus 12 over 5J.
Is it not plus 12 over 5?
Minus 12.
Look, 3J is bigger than minus 3 is bigger than minus 3 over 5, okay? So it should be
yeah.
positive. No? Okay, sure. I'm sure that's how I wrote it down, right? Okay. So let's go to the C part. It was just accidental. Let's go to the C part, guys. Now the screen is just freezed up. Okay, that's interesting. Wow. Okay, I don't know. C. So I'm just trying to do some writing now on it. C. Oh, then it comes up double again. Okay, great. Okay, let me try and be quick with this discussion. We've got 2 minutes. I might go a minute over, guys. Let's see. I know some guys are writing to some other sessions. Let's see quickly. Right. So, great. So the C part, I need you to solve the following. Where is that? No. Let me just try. I'll try and do it very quickly. C part. It's stuck now. So it says that J to the 8. So like I said, guys, instead of using I use J to the 8 minus 1 over J to the 6. Plus minus J cubed and then we've got a negative 7 multiplied by minus J cubed. Okay. So I'm gonna use some prior results that we had, and then it should be fine. What is this? 7 times 1 minus J cubed. Sorry, guys. Okay. 1 minus J cubed. No? That's all cubed. Okay. Guys, just double check whether I wrote down things correctly here. Seems fine. Right. So what I would propose is you take it like this. This is how I would propose it. We know that J squared, is equal to minus 1. Right? J squared is minus 1. And there is J to the 8. So from the law of exponents, we can just write this as J squared to the 4. And we know inside there, we've got J squared, which is minus 1. And minus 1 raised to an even exponent is 1. So inside there, we've got J squared, which is minus 1, and minus 1 4 times is 1. Then we see that this J to the 6 can be written as J squared times J squared times J squared, okay? We can write it as J squared to the 3. So inside, you've got minus 1 again, and you raise it to the exponent 3, which is negative 1. Okay. And this one says negative, there's a negative 1 in front of the J. So it says that negative 1 times negative 1 times negative 1 is negative 1. And then you've got J cubed, which is J squared. times j. So -1 here times -1 3 times -1 3 times, right? -1 times itself 3 times gives you -1, and then j times j is j squared times j is j cubed. Then what you can do with this one here, you can split it up, keep the 7 outside, and then write this as follows. Write this as follows. Write this is 1 minus j squared, and then do those multiplications like we did, because we did this kind of multiplication. Right? And then multiply by 1 minus j again. So there you didn't need to use conjugates. Right. So I'm going to do it all for you guys. So, so this is -1 to the 4, which gives you 1. And here you've got -1, so j squared is minus, so it's +1. And then j squared is minus times minus a plus, so it's plus j. Right? And then all you have to do is keep that 7 outside and just multiply this one out here. Just multiply this one out by itself 2 times, right? Already we can see 1 squared is 1. Remember, we do only this when the exponent is 2. 1 times 1, that's 1. Minus 2 times 1 times j. So minus 2 times 1 times minus j. So it's 2 times 1 times minus j, it's minus 2j. All right. So we've got that term. And then we've got minus times a minus in front of the j is a plus. And then j times j is j squared. J times j is j squared. Okay. All right. J squared. Close the bracket. And then that last bracket is just 1 minus j. So you can see what I've done. I looked at j, then I took that 7, that -7, I kept it there. And I just said 1 minus j squared, it's 1 times 1. So it's squared, so it's 1. Then I said 2 times 1 times minus j is minus 2j. Then I said that minus in front of the j, it's -1 times -1 is +1. J times j is j squared. And then this term here, I leave it for now. It doesn't interfere with us. You'll see things will work out nicely. And you guys will notice something coming up. J squared is -1 here. J squared is -1. Right? -1. +1 is 0. Right? So look at things unfolding now. So multiplication becomes easy. So you've got 2 plus j. And then keep that -7 outside. Keep that -7 outside. So it's 2 plus j. Why is the j not coming up now? So -1 plus 1 is 0. So I've got -2j times 1 minus j. So this is 2 plus j. Okay. Right. Okay, guys. So there's that. That's how it looks. And now the rest are relatively easy to resolve. If my calculations are still fine and don't make any blunders, then you guys can just multiply those brackets now. So it's 2 plus j. So I've got 14j times that. 14j times 1 is 14j. It's 14j. And then I've got 14j times minus j. Well, 14j times minus j. So J squared is -1. So it's +1. So I get 14J. I want you guys to double check that for me, guys. It seems fine. Yeah, seems fine. So in the final analysis, I get an answer of 2 plus 28J. I hope there was no cancellations, but yeah, it seems okay. You just see 14J times 1 is 14J minus J squared, that's +1. Yeah, minus J squared is +1. So I get an answer like that. I don't know what they say there in the activity. I think the answer is on page 105, guys. Did I miss something? They get 16 plus 15J. So we made a blunder somewhere, and I'm not sure where the blunder lies. Okay, -1.
I think you left out that first J after the 2 plus J.
The first J after the 2 plus J. The first J. Oh, okay, but there's still something more missing. I left out this first J here, guys. I don't know, probably because my things are not working well on the screen. This one here, and this J there, that 2 plus J, né? But I think it's still something else that's wrong there. Because they have an answer of 14 plus 14J. So there seems to be some cancellation somewhere that happened. Oh, okay. I see now. No, it's fine. I have everything now. Okay, great. Thanks for telling me that. So I think there's a minor error that creeped up with our multiplication and the way I rewrote things. And he pointed out I omitted to write the J which I had on top. So let's start afresh at the bottom, guys. Okay, just bear with me. And my screen is just freezed up sometimes, so and it stirs my thoughts. Okay, I think we're fine. I think you reminded me of that, J. So let's do this systematically. Plus 14J plus 14J. So it's plus. And then we've got 14J times minus J, which gives us 14. Yeah, which gives us 14. Because J squared is -1 times 1 is +1. And then it's 16 plus 15J. But this one here, I'm worried now because they get their answer is 14 plus 14J. We get 16 plus 14J. We get 16 plus 15J. That's what we get. They get 14 plus 14J. So let me just check whether we wrote down everything correctly, guys, and go through those steps again. So sorry for that, guys. Let's just try and pick up how we wrote down things and see if there's any error there. It's activity number 3. Okay, so we wrote down J to the 8 minus 1 over J to the 6 plus minus J, and then we cube everything inside, minus 7 times 1 minus J cubed. So that's fine. And then we said, okay, but J to the 8 can be written as J squared to the 4, and it's -1 to the 4 is 1, okay? Then J to the 6 we split up as J squared to the 3, and there was a minus outside. That's correct, right? Oh, okay. Yes, oh, that's fine. Everything's written out correctly. So we've got J squared is -1 times, and 1 minus 1 cubed, it's -1. So -1 times -1 is +1. And then we split up that, we said -1 cubed, it's -1. We split up the J, it's J squared and J, so it's +1, so it's plus J, so that's fine. And then we keep the -7, we say 1 minus 2J plus J squared, right? Plus J squared, that was fine. And we kept that one outside. And then we've got 2 plus J, so inside there was a -1 plus 1, it was 0. And then we have that. I don't see our error here, guys. I don't see our mistake. 16 plus 15J. I don't see our mistake. I can't see our error. They have 14 plus 14J, okay? But let's have a look at it again. See if you guys can detect an error. I can't see an error. Their answer is 14 plus 14J, okay? Yeah, the answer is 14 plus 14J. Right. So I suspect minus 1 minus. I suspect they made an error with the signs so that 1 minus 1 is 0. And then there's possibly, yeah, I suspect they probably did an error with the signs. So it's minus 1 plus 1 plus
So
J.
sorry,
Hello?
the answer
Yes.
is the same with ours. It's 16 plus 15J.
Yes, our answer, yeah, yeah.
It's also theirs.
Is it this? What do I read?
Yes, you can see they said the term 4 is the 14
What
plus
which
14J.
page is it, please? I don't know.
105.
Page what?
105.
Page 105. Oh, okay, sorry. It's our answer. Sorry. Okay. Okay, now we have this. Sorry, I was looking at something else. Sorry, guys. Sorry for that. Our answer is like this. Sorry. Thanks for that. But I was just confident that we worked correctly. That's why I don't want to entertain it anymore. Okay. Okay, guys. So I was wrong with what I read down. Our answer agrees with theirs. Okay. Thanks for that. Okay.
Yes.
Okay. I'm sorry for that delay, guys. I don't know what's my pen is acting up again, Ms. Prim. But yeah, it's fine. It's fine. Okay, thanks, guys. No?